Welcome to session. Today we will study ray diagram of convex and concave lenses. So focus on the screen. So before we draw a ray diagram for any lens, we need to know about principal light rays. There are three kinds of principal light rays. If you see on your screen, the first kind of principal light ray is if any incident light ray, if it passes through optical center of the lens, then it is refracted without any deviation. So if you see in the figure, the first lens is convex lens and the incident light beam is passing through optical center. Okay, and it is refracted without any deviation. So the incident ray travels after refraction in the same direction and path. The same case with concave lens on the right side. The incident light ray which is passing through optical center passes after refraction in the same direction and path. So there is no deviation when an incident light ray passes through optical center. This is the first principal light ray. Okay, the second principal light ray is when a light ray is incident parallel to the principal axis. So first you see the convex lens here. So this light ray is parallel to the principal axis. So this is principal axis. This is the principal axis. So the light ray is incident on the lens surface parallel to the principal axis. So such a light ray, after suffering refraction, will pass through the focal point on the principal axis. So this is second kind of light ray, principal light ray. So on the right side, if you take concave lens, the incident beam of light or incident light ray is parallel to the principal axis. After suffering refraction, the light ray is refracted in a direction. When such a refracted ray is drawn backwards, it appears as if it is emanating from focal point on the principal axis. So this is second kind of a principal light ray. The last kind of a light ray is, suppose the incident light ray passes through focal point and reaches the lens. After refracting through the lens, the incident light ray is refracted parallel to the principal axis. So this refracted ray is parallel to the principal axis. So this is third kind of principal light ray. The same thing for a convex lens, concave lens. If this is the incident light ray, okay, in such a way that when it is drawn, it appears to pass through focal point, then such a light ray, after suffering refraction, it travels parallel to the principal axis. Okay, so these three are the principal light rays that we need to consider when we draw a ray diagram for convex or concave lens. So the first principal ray is the light ray which travels through optical center and it after refraction travels in the same direction and path without any deviation. The second kind of principal ray is when the incident light ray is parallel to the principal axis. After suffering refraction, it travels through the focal point on principal axis or appears to be emanating from principal point on the focal point on the principal axis. Then the third and last kind of light ray is principal light ray is when a incident light ray passes through focal point on principal axis. Then after suffering refraction, it travels parallel in case of convex lens. Then in case of concave lens, an incident light ray which when drawn further appears to pass through focal point. After suffering refraction, it travels parallel to the principal axis. So these are the three kinds of principal light rays that we need to consider while drawing ray diagrams of convex or concave lens. For any point source to get an image, you need at least two principal light rays passing through that point. So if you are considering an object or the top of the object, so at least you should consider two principal light rays at that point to arrive at the image point of the corresponding object point. Okay. So if you focus on the right side of the screen, so here AB is the object. Now the first kind of principal light ray, it is emanating from point A and is incident along AO, and it is passing through optical center, so it is undeviated and it passes further like this. Okay, this is the first principal light ray that we have considered. Now from the same point A, if you are considering second kind of principal light ray, that is the light ray is incident parallel to the principal axis. After suffering refraction through lens, it passes through the focal point. Okay, so if you see, these two light rays are enough to arrive at the image point A dash. Similarly for B point, any two of the three principal light rays are sufficient to arrive at the image point B dash. Here, like they have considered the third kind of light ray, which is passing through focal point on principal axis and reaching the lens. After refraction, it is refracted parallel to the principal axis. So all these three principal light rays meet at point A dash, which is the image of point source A. Likewise, the image of point source B can be arrived at B dash. So if you see, AB is the object and A dash B dash is the image of the object. Here the image is real, the image is inverted. Okay. Similarly, if you draw the ray diagram for a concave lens, let AB be the object and point source be A. So from point source A, if you want an image of A, consider first kind of principal light ray, which is emanating from point A and passing through optical center, and it passes undeviated in the same direction and path as shown here. Then consider second kind of principal light ray, AD, which is incident on the lens surface parallel to the principal axis. After refraction, it is diverged, and this divergent ray, when drawn backwards, passes through the focal point F2 on the principal axis. So these two rays are meeting at point A dash. These two principal light rays are sufficient to arrive at the image point A dash. Another third kind of a light ray, AD dash, is considered incident on the lens surface. This light ray would have passed through the focal point F1 had there been no lens. After refraction, such an incident light ray AD dash is refracted along DZ. Okay, so when this refracted ray D dash Z is drawn backwards, so it will meet all these three, that is two emergent rays drawn backwards and the incident ray AO will meet at point A dash, which is the image point A dash. This is A dash is the image point for source point A. Likewise, B dash is the image point of source point B. So if you see here, if you observe, AB is the object and A dash B dash is a virtual image. There is no actual intersection of uh, refracted rays in this case. For an observer observing from this side, these divergent rays appear to be emanating from a point, but in fact they never actually meet. That's the reason why A dash B dash is called as a virtual image. It can never be captured on a screen. Moreover, this image is upright or erect. In case of convex lens, it is inverted, whereas in case of concave lens, it is erect and upright and it is virtual. Clear? So by this time you have an idea of real image and a virtual image. So a real image is formed in case of convex lens when there is actual intersection of refracted rays happening. So the refracted rays are actually intersecting at a point. So that's why the image formed is real. Whereas in case of concave lens, the refracted rays never meet at a point, but they appear to be emanating from a point where the image appears to have formed virtually. So such a virtual image can only be observed but cannot be captured on a screen. So in case of virtual image, there is no actual intersection of refracted rays. Then second point is real image is inverted, whereas virtual image is erect. Then the third point is, as told already, real image can be captured on a screen, whereas virtual image can never be captured on a screen. It can only be observed by an observer. Example of real image are projector, camera images, all these are real images. And example of virtual images, a magnifying glass. Okay. So now we will see how to draw ray diagrams for a convex lens and then concave. Let's construct a ray diagram for a convex lens. First, draw a horizontal line which is going to be our principal axis. Okay. Now, approximately at the center of the horizontal line, mark a point. This is going to be our optical center O of the convex lens. Assume the thickness of convex lens is going to be 2 centimeters. Therefore, just mark 2 points, 1 centimeter on the either side. So 1 centimeter on the either side of optical center, that means we have the thickness of lens at the center 2 centimeters. Now with an approximate radius, some arbitrary approximate radius, you locate the needle point of a compass on the principal axis such that the pencil point matches with the one surface of the convex lens and draw a curve. This is going to be the first refracting surface of the lens. Now match the pencil point with the 1 centimeter mark we have marked on the other side of the optical center, and draw the second refracting spherical surface using the same radius. Okay, so we have a convex lens now. So mark the focal point on either side, which are equal in distance. So generally we can take center of curvature of the focal point. Now the distance, focal distance from the optical center is approximately 5 centimeters. So I will mark the second focal point at 10 centimeters on the other side. Okay. So F1 first focal point, 2F1 second focal point, F2 first focal point on the left side, and 2F1, 2F2 second focal point on left side. Now draw the center line of the lens which intersects principal axis at the optical center. Okay. So we are aware of three principal rays that help us to draw ray diagram of lenses. The first principal ray is which is incident on the optical center of the lens that passes undeviated after refraction. The second principal ray is incident parallel to the principal axis. After refraction, passes through the focal point on principal axis. The third principal ray is that which is incident through the principal focal point, and after refraction is refracted parallel to principal axis. So these are the three principal rays that we use to draw any ray diagram. At least two of these principal rays are required to form the image of any point source. Okay, first let us draw an object on the left side to some scale. So I am drawing an object of approximately 3 centimeters. So this is an object. Now the first principal ray that we consider is, suppose I want to form the image of the top of the object, so the top point of the object. So the first principal ray is the one that is incident on the optical center of the lens and it passes undeviated. So this is our principal ray first. So I will mark the direction using a red. So this is first principal ray that is incident on the optical center and after refraction passes undeviated. So the second principal ray is the one that is parallel to the principal axis. So let me draw it with blue pen. So this is the second principal ray. Incident parallel to the principal axis. After refraction, this principal ray will pass through the focal point. Let me mark the direction of the refracted ray. Okay, so you see, with just two principal rays, we have identified the image point of the source point. So if I name the source point here as A, so image point would be A dash. Okay. So similarly, if you consider an incident ray that is incident along the principal axis to form the image of base point of the object. So this is all following through optical center and it will pass along the principal axis. So now, using these three rays, we can identify easily the image of the object. So the image of the object is drawn with green ink, and A dash is the top of the image of the object. If B is the base of the object, then B dash is the image of the base. Now if you see, the object is approximately of 3 centimeters height. The image is approximately 2.4 centimeters. So this is the ray diagram using a convex lens. Let us construct a ray diagram using concave lens. So first draw a horizontal line that represents principal axis. Approximately mark an arbitrary point at the center of the line which represents optical center O. Assuming the thickness of the concave lens is going to be 1 centimeter, so I will mark half centimeter point on either side of the optical center. So your reflecting spherical surface should pass through this point at the optical center. Using some arbitrary radius, match your pencil point on the left side pencil mark and draw the first spherical surface of the concave lens. With the same radius, match the pencil point with the pencil mark on the right side of the optical center and locate the needle point of compass on the principal axis and draw the second spherical surface of the concave lens. Now Draw the horizontal portion of the lens. So this is how your concave lens looks like. Now mark the focal points. Mark the focal points F1 and F2. The focal distance is approximately 6.5 centimeters. So take 13 centimeters as your second focal point. So let me extend the principal axis beyond the second focal point. And the same thing on the other side. So 13 centimeters. So this is your second focal point on the right side, and this is your second focal point on the left side. Now consider an object. Before drawing the object, let us draw the central line of the lens, so which is perpendicular to the principal axis and passing through optical center. So this is center line of the lens. Now draw an object of approximately 2 centimeters at some point on the principal axis. So this is the object. Now the first principal ray that should pass through the optical center will pass undeviated. So I am drawing. So I am drawing the first principal ray passing through the optical center of concave lens. And I am marking the direction of the light ray. The second principal ray should be incident parallel to the principal axis. So let me draw with red, or maybe, yeah. So I'm drawing the second principal ray using red color. So this second principal ray after refraction appears to emanate from focal point F1. So this is your refracted ray, and if the refracted ray is drawn backwards, it will pass through the focal point F1. So the point source of top of the object, let it name it as A. So the point of intersection of this backwards drawn refracted ray and the incident ray passing the optical center. So this would be the image of the top of the object. And if you consider a light ray that is passing, that is incident from the bottom point of the object and passing through optical center. So if you draw a vertical line at this point A dash, This would be your image. So this is the ray diagram. If you observe the size of the object, it is approximately 2 centimeters long, whereas image it is approximately 1 centimeter. So another point to note is here the image is erect and the image is virtual. There is no real intersection of refracted rays. Only when an observer from this side watches, he he sees a virtual image of the object at point A. So let me name the bottom point. If it is B, then bottom point of image would be B dash. So for the object AB, an observer will observe a virtual image at A dash B dash.